Deep in a remote timber region, workers uncover something they don't expect. Logs, massive ones, wider than a car, older than most nations on Earth. Some of these trees started growing before recorded history began, before empires, before written language in some parts of the world. Now they're being pulled into a processing facility built to handle wood on an industrial scale. But this isn't ordinary lumber. These are trees that stood untouched for centuries, maybe longer, and the operation moving them is unlike anything most people have seen. Massive machines, enormous saws, a process built to turn ancient giants into usable material within hours. Workers say the scale alone is hard to process. Engineers say the wood behaves differently than anything they've handled before. And somewhere in the middle of this operation, a bigger question begins to form. If these trees have survived for 1,000 years, what changes the moment they're gone? What happens to the land they leave behind? And why did this operation begin in the first place? To understand that, we have to go back to where it started. The story begins far from any factory. It begins in a forest that few people ever enter, a stretch of dense woodland tucked into a remote valley, where the trees grow slower than almost anywhere else on Earth. Local foresters had known about this region for generations, but even they didn't know how old some of these trees really were. For decades, this land sat outside major logging routes. Too remote, too difficult to access, too costly to justify large-scale harvesting. That changed when a timber survey team was sent in to assess the region for future resource planning. What they found surprised even experienced foresters. Trunks with growth rings suggesting ages far beyond typical harvest trees. Some appeared to predate any written record of the region's history. One senior surveyor later admitted the readings looked wrong at first. He assumed equipment error. He checked again. The numbers held. These weren't just old trees. They were living structures that had survived storms, droughts, and centuries of changing climate, all while standing in near total isolation. Word of the discovery moved quickly through regional forestry offices, and with it came a decision that would set everything in motion. A large-scale harvesting and processing operation was approved, not for ordinary timber, for these trees specifically. Workers were told the wood held unusual density, unusual strength, and unusual commercial value. But few of them understood what they were about to take part in, because ancient trees don't just represent age. They represent an entire ecosystem built silently around them. And once the first cutting equipment rolled into the valley, that balance began to shift, quietly, almost unnoticed at first. The first machines arrived at dawn. Heavy transport trucks, mobile processing units. Engineers spent days just preparing access roads strong enough to carry the equipment. The trees they were about to cut weren't like anything in a standard operation. Some trunks measured wider than the trucks meant to haul them. One equipment operator recalled staring up at a tree and losing count of how many workers it would take to wrap their arms around it. Cutting began carefully, almost cautiously, but caution didn't last long. Once the first tree came down, something changed in the air of the operation. Workers described a strange silence in the moments right after. No birds, no movement in the canopy above. Just the sound of settling wood and diesel engines idling nearby. Then came the discovery that unsettled even the most experienced crew members. Beneath the bark of several ancient trunks, engineers found unusual internal patterns. Growth rings compressed in ways that suggested extreme environmental stress centuries earlier. Evidence of long droughts. Evidence of fires the forest had survived, but barely. One forestry official said it felt less like cutting timber and more like opening a historical record no one had asked to read. But there was no time to slow down. Quotas were set. Machinery kept moving. Then, during the third day of operations, one crew noticed something in the forest floor they hadn't expected. Something that shouldn't have been there. Something that made two workers stop mid-task and call for a supervisor immediately. The supervisor arrived within minutes. What he found stopped the entire crew in place. Exposed beneath the roots of a fallen giant was a section of soil unlike anything nearby. Darker, denser, almost undisturbed for what looked like centuries. A field researcher, brought in for environmental assessment, knelt down to examine it closer. He noted something immediately. The soil beneath these ancient trees wasn't ordinary forest ground. It was a slow-formed layer, built up over hundreds of years, shaped entirely by the tree's own root system and decay cycle. In simple terms, the tree hadn't just lived on the land. It had built the land around itself, and now that structure was gone, removed in a single afternoon. The researcher raised a concern to the site manager. If this pattern held true across the rest of the valley, the ecosystem beneath these ancient trees might be more fragile than anyone accounted for. The response was measured but firm. Operations would continue. Environmental reviews would happen later, not now. That decision would matter more than anyone realized at the time. Because 2 days later, after nearly a dozen ancient trees had already been processed, the crew noticed a new problem, one nobody had expected. Sections of the forest floor, once solid enough to support heavy machinery, had begun to shift. Not dramatically, not yet, but enough for one truck operator to feel something give slightly beneath his vehicle. He stopped immediately and called it in. Something underground was changing, and no one yet understood why. By the next morning, the concern had a name: ground instability. A geotechnical engineer was called in to inspect the site. He walked the same paths the trucks had used for days, checking depth, checking density, checking for anything that explained the shift. What he found didn't fully add up. The soil wasn't collapsing from weight, it was collapsing from absence. For centuries, the root systems of these ancient trees had done more than anchor them. They had quietly reinforced the ground, channeling water, stabilizing slopes, holding entire sections of the valley floor together. Remove the trees, and that support system disappears with them. Not instantly, but steadily. The engineer flagged the finding as urgent. If harvesting continued at the current pace, sections of the access roads, and potentially the processing site itself, could become unstable within weeks. Management pushed back. Timber quotas were already behind schedule. Buyers were waiting. A partial halt was allowed, but only in the most affected zone. Everywhere else, cutting continued. Then came the incident that changed the tone of the entire operation. During a routine transport run, a loaded truck crossing a previously stable section of trail felt the ground shift beneath its rear wheels. The driver reacted fast. He gunned the engine, cleared the section seconds before a visible section of trail dropped several inches. No one was hurt, but everyone on site understood what had almost happened. This wasn't a soil problem anymore. This was a warning, and the forest wasn't finished revealing what it was hiding. Within 24 hours, regional forestry officials suspended the operation entirely, not as a precaution, as a requirement. An independent environmental team was brought in to assess the full valley, not just the harvest site. Their findings confirmed what the geotechnical engineer had feared. The ancient trees weren't isolated organisms. They were structural anchors for an entire hillside ecosystem built up over hundreds of years of root growth, water regulation, and soil formation. Remove enough of them, and the land beneath the valley loses the framework holding it together. The report was blunt. Continued harvesting risked long-term slope failure, affecting not just the forest, but nearby access routes and water drainage for the region. Faced with the data, officials made a final decision. The remaining ancient trees would be left standing, permanently protected under emergency regional order. The wood already processed was reclassified, some of it preserved for scientific study instead of commercial sale. Researchers say the growth rings from these trees are now being used to study centuries of climate patterns, information that couldn't be replaced once cut. For the workers who took part in those first weeks, the experience left a lasting impression. One equipment operator said it plainly. He didn't think of it as cutting wood anymore. He thought of it as taking something apart that took hundreds of years to build and only days to unmake. Today, the valley is quiet again. Machinery gone. Access roads slowly reclaimed by undergrowth. The remaining ancient trees still stand, taller than anything built around them, holding a history few people ever got to see up close. If stories like this one interest you, stories about nature, scale, and the hidden consequences of human decisions, consider subscribing. There are more of them waiting to be told.